Welcome to this video, part 2 for standard drilling operations. Before using a drilling machine, it's very important to use the correct PPE. This entails the use of goggles over existing safety glasses. Any jewellery, loose clothing, long hair or any other item that could get caught in the machinery should be removed or secured before entering the workshop. Drilling machine guards are correctly adjusted and in place. The machine is isolated before mounting tools, changing speeds or work holding devices. Table height and position adjustments are clamped correctly. Make sure that the emergency stop buttons are in the active position. When drilling for tapped holes, it's important to check for the correct hole sizes. Recommended drill sizes can be found in engineering data charts and tables, or these can be calculated by subtracting the pitch of the thread from the thread diameter. A chuck is a specialist clamp that comes in many sizes and is used to hold objects in place, usually with radial symmetry, and most commonly used to hold rotating tools. A centre punch is the appropriate tool followed by a centre drill to spot a hole before drilling. This prevents wandering when starting the drilling procedure on an unprepared surface and also acts as a visual guide to ensure accuracy. Make sure that the guard is securely in position before operating any machinery in the workshop. The correct feeds and speeds are set. Cutting speed of a material is the ideal number of meters per minute that the tool bit should pass over the workpiece. Different materials such as high carbon, low carbon steels, aluminiums and different kinds of plastics have different cutting speeds. Some tools or processes like threading, knurling or cutting off will need to be worked at slower speeds. After centre drilling at the appropriate speed, remove the centre drill and replace with a twist drill, selecting the appropriate speed according to the size of the hole and material. When inserting or removing a drill from the drill chuck, remember always to remove the key from the chuck. Never leave a chuck key in the chuck under any circumstances. Once the drill is set, make sure that the protective guard is securely in position. Drilling can then commence using light pressure and retracting the drill periodically to prevent swarf from building up. RPM, revolutions per minute, is the turning speed of whatever is spinning. On a lathe, this is a workpiece. On a mill or a drill, it is the cutting tool. Using cutting speed and diameter, you can calculate the RPM. When calculating spindle speeds RPM, round down to the slower speed option offered by your lathe, milling machine or drill. Depending on the purpose, various tools can be used. Here we show a counterboring operation. Make sure that the counterbore is secured and set to the correct speed according to the workpiece. A counterbore hole is typically used when a fastener such as a socket head cap screw is required to sit flush with or below the level of a workpiece's surface. Counterboring usually requires the depth of the cut to be set. Never drill or ream a workpiece that is not clamped securely. And never remove swarf with bare hands. Cutting speed of a material is the ideal number of meters per minute that the tool bit should pass over the workpiece. A counterbore hole is typically used when a fastener such as a socket head cap screw is required to sit flush with or below the level of a workpiece's surface. Similar to counterboring, a countersink can be used as shown here. Countersinks provide the profile for countersink screws. Again, use light pressure and retract the countersink drill periodically to prevent the swarf from building up. The countersunk hole has the top part enlarged so that the head of an angled screw or bolt will lie flush with or below the surface.